Quick intro. Let's have a quick talk about the test cycle while we cool down from our exciting talk about the SDLC. Forget computers for a minute and imagine that you've just bought a super-duper vacuum cleaner. How would you test it? After you remove it from the box, you'd probably read the manual and then torture the poor thing until you're sure that it really works. This wouldn't require too much thinking about the process, but let's look at the stages of that process on an abstract level. 1. The instructions have been read and understood. For example, the description from item 22.1 of the manual on the wet cleaning mode. 2. A plan has instantly developed in your brain. For example, A. Pour water into the upper water tank. B. Press the power button. C. Press the pressure button. 3. The steps from the plan have been implemented, meaning that you actually tried wet cleaning. Let's jump from vacuum cleaner testing to software testing. The software testing cycle, or test cycle, consists of 3 stages. 1. Research. 2. Test planning. 3. Test execution. At any of these stages, testers can find a bug. The bug must be fixed by the responsible party, and the fix must be verified by the tester. Let's link the test cycle with the SDLC. 1. Research starts before spec approval, which comes at the end of the product design stage and continues through coding stage. Testers get their first look at the spec before the spec review meeting, and they keep researching the features that they are going to test while writing their test cases. 2. Test planning takes place at the coding stage when testers write their test cases. 3. Test execution takes place at the testing and bug fixes stage when testers execute their test cases. We've just looked at how the test cycle is typically integrated with SDLC. The key word here is typically. In reality, there will be a huge number of not typical situations. Example: the test manager tells you you have 30 minutes to test a certain feature. For example, registration. You have to use your common sense because there is no documentation and no time for inquiries about how it's supposed to work. In this situation, your research, planning, and execution all take place at the same time. Let's review all 3 stages of the test cycle. Research. The subject of the research is basically what is going to be tested. Question: why do people need software in general and websites in particular? Answer: to satisfy certain needs. For example, to buy books, read news, share videos, check credit card balances, etc. Question: how can we as software professionals satisfy those needs? Answer: we have to come up with marketing person and PM, write, programmer, test, tester, and release RE. Concrete means to satisfy those needs. These concrete means consist of user-oriented features. It's no surprise that most, or sometimes all, of the efforts made by testers are related to the testing of those features. By the way, a logical question is what features are not user-oriented? There are many features that can be developed for usage inside the software company. For example, reporting, infrastructure, admin interface, performance, etc. For the sake of this course, we'll concentrate on user-oriented features. We'll simply call these features. Some examples of features: a user can search book titles. A log-out link is displayed only if the user is logged in. A user can update the quantity of books inside the shopping cart. What is the main source of information about features? Documentation, for example, specs, user stories, mock-ups, flowcharts, and other documents describing the features of our website. An example of other documents could be instructions from our business partner about the file format for credit card transactions. Humans. Communication is an extremely important source of information. If you are in doubt about some of the spec provisions, feel free to approach the PM and ask as many questions as needed. In cases where there is no documentation and the features are not yet available for testing, your colleagues that have knowledge about the feature are the primary sources of information. The website itself. You can also learn about features by exploring previously written software, for example, the website. Let's discuss the concept of exploration. Each of us does this when we visit a website, fill in and submit forms, click links, and perform other actions that assist us to understand the website features. In Internet startups, exploration usually takes place in two situations. First, when the code has been written but the documentation is missing. Very often the first tester in the startup finds himself in this situation. Second, for self-education. When you come to a startup company, they usually give you some time for getting started. Everyone is extremely busy, and as a rule, nobody is going to babysit you. What sources for expected results do we have during exploration? Primarily our old friends' common sense and life experience. Exploratory testing is also called ad hoc testing. By the way, a very good way to better comprehend the features of the product is to become a regular user. Go to the production environment, create an account, and do whatever other users do. Why? Because you'll take your understanding of the product to another level. It's one thing to be a chef in the restaurant and another thing to be a customer. It's a totally different perspective. Besides, you might get familiar with features that you've never used before. The expression "to eat your dog's food" applies to testers this way. If your internet company sells books, you should buy books from your company. It's also very useful to become a customer at your competitors' websites. The main purpose of the research stage is to answer two questions. Which features are we going to test? How are those features supposed to work? When we have the answers, we could proceed to the next stage. Test planning. This stage requires a lot of creativity and the full use of professional skills, because here many puzzles are solved in order to answer one very simple question. How are we going to test these features? The quality of the product will be seriously impacted by the wisdom of the decisions made here. That wisdom is reflected two ways. A. Finding short, simple, and elegant ways to test our features. B. Finding a compromise between the volume of testing that is possible in theory, the volume of testing that is doable in real life. The answers to this one very simple question are reflected in the test documentation. Just as the human body consists of cells, test documentation consists of test cases. Sometimes testers create additional pieces of test documentation, test plans for instance, which we'll talk about later. Test execution. The gist of test case execution is conducting a practical search for bugs in the code by using test cases that we've created during the previous stage. Each test cycle includes two main activities: new feature testing, regression testing. First, we perform new feature testing using new test cases. As you recall, new test cases are often modified during their first execution. Second, we perform regression testing using old test cases. During both new feature testing and regression testing, we try to find bugs. Remember, once a bug has been discovered, the tester should file a bug into the bug tracking system. After a programmer fixes the bug, the tester checks to see A. If the bug was really fixed. Hence, the tester tries to reproduce the bug. B. If the activities during the bug fixing stage have unintentionally introduced new bugs. Hence, the tester does a quick test of the features that could have been affected. The testing performed during steps A and B is also called regression testing. Thus, the expression "regress that bug" means that you have to perform the testing specified in those two steps. Because the stages research and test planning are intermingled, we'll unite them into one body of knowledge called test preparations, or test preps for short. Therefore, the majority of our future lessons will be dedicated to 1. Test preps, 2. Test execution. Test education and reality. One of my main purposes for this course is to promote flexibility as one of the most important qualities of a tester. In each particular software company, some things like processes or standards of test documentation will work, or look differently from what we've discussed. In school, if you learn that 2 + 2 = 4, you can be confident about the truth of that forever. In testing, you'll be constantly learning new facets about things you've been confident about. Flexibility is required here. So when we state that there are 2 stages in the test cycle, you should be ready to experience a situation that might sound illogical at first, but can easily take place in real life. For example, you are given 30 minutes to test certain features, and after its release, your manager asks you to create documentation for it. Learn all you can, but not in a dogmatic way. Instead, try to understand the essence and remember that in software testing, nothing is set in stone. Lesson recap. 1. The test cycle consists of 2 stages, test preps and test execution. 2. During test preps, we conduct research and write test cases. 3. The main sources of knowledge about a product's features are documentation, humans, exploration. 4. Good exploration skills require a quick understanding of how the software features work. 5. Test preps require great creativity and professionalism because test execution follows the testing ideas developed at this stage. Good testing ideas assist us to find bugs. 6. Main activities during test execution are new feature testing and regression testing. 7. Bug fix verification is also called regression testing. 8. Be creative and flexible. Nothing is set in stone in the QA profession.